These are the notes for similar triangles. So in Unit 3, we talked about congruent triangles. In congruent triangles, we knew that all three pairs of corresponding angles were congruent, and we knew that all three pairs of corresponding sides were congruent. So the triangles were the same size and the same shape. Okay, they were just located in different areas of space. Okay, they were just occupying different areas, but they were the same size and shape. All their angles were, all the corresponding pairs of angles were congruent, and all the corresponding sides were congruent. Okay. Similar triangles are going to have the same shape, but they're going to have different sizes. So an example here, we have triangle WVU and triangle ZYX are similar triangles. We denote that they're similar triangles by the tilde, okay, or half of an infinity sign if you want to think of it that way. Just a little squiggly line. The tilde tells us that triangle UVW and triangle XYZ are similar. So similar triangles are the same size or same shape, different sizes. So the reason they're the same shape is because their corresponding angles are the same. Angle W and angle Z are going to be congruent. Angle U and X are congruent. And angle V and angle Y are congruent. So the angles, the corresponding angles are going to be congruent. The angles that correspond with each other are congruent. And that's the same as in congruent triangles. Okay, where we did make a differentiation with congruent triangles is in the corresponding sides. In congruent triangles, the corresponding sides are congruent. In similar triangles, the corresponding sides are proportional. Okay, so what we're going to do to represent that is we're going to set up ratios, okay, to represent each pair of corresponding sides. So let's talk about proportion and ratios for a second here. Okay. So ratio is going to be a comparison of two values. It doesn't have to be expressed as a quotient. It doesn't have to be expressed as a fraction, but that's how we're going to do it in order to solve problems here. The example that is listed here is that you have a classroom with 12 girls and 18 boys. So the ratio of girls to boys is 12 to 18. Okay, and then we can reduce this fraction down to 2/3. And if we divide the numerator and the denominator each by 6, we would end up getting 2/3. A proportion is when we set up an equation where we put two ratios equal to each other. So a ratio, we're comparing two values. So in this case, we're comparing the ratios of girls to boys. Let's say it's the girls to boys in first hour. Okay, let's say 12 to 18 is the ratio of girls to boys in first hour. And let's say the ratio of girls to boys in second hour is 10 to 15. Okay, let's say, yeah, that's going to work, 10 to 15. So there were 10 girls in second hour and 15 boys in second hour. So our ratio is going to be 10 boys to 15 girls. So here we now have two ratios. Okay. This represents first hour. First hour has 12 girls and 18 boys. Second hour has 10 girls and 15 boys. So the ratios are 12 to 18 and 10 to 15. Those two ratios are going to be proportional, directly proportional, if those ratios are equal. Okay. If the ratios are equal. So if our fractions are equal, then our ratios are proportional. So if we reduce this, if we can, again, divide the top and the bottom by 6 each, we reduce the fraction to 2/3. Okay, and we can do the same for 10/15. We can reduce the fraction to 2/3. This time you divide the numerator and the denominator each by 5. So we reduce those fractions and we get 2/3 equals 2/3. Okay. Since these two ratios are equal, they're going to be proportional. So the amount of girls to boys in first hour and the amount of girls to boys in second hour, okay, the ratio of girls to boys in first hour and the ratio of girls to boys in second hour are equal. Therefore, the amount of girls to boys between first and second hour is proportional. The ratios are equal, so they are proportional. Okay, when we talk about triangles, similar triangles, we're talking about specifically are these sides. Okay, we're talking about these sides of the triangle. So UV, what's the corresponding side to UV? It's going to be XY. They represent the corresponding sides of those triangles. So we can set up a ratio. Okay, ratio relates two values. So we're relating the corresponding sides of the two different triangles. So we're relating UV to XY. Okay. Then we're relating UW to XZ, and we're relating VW to YZ. Okay, so each one of these is a ratio. So we have three ratios representing each of the corresponding sides. Two triangles have similar triangles, okay, have three pairs of corresponding sides. Okay, so each ratio represents one pair of those corresponding sides. Okay, but we know in similar triangles, the corresponding sides are proportional, meaning all the ratios are equal. Okay, so we can set up a proportion like this. We want to set ratios equal to each other. Okay. So similar triangles, here's our symbol for similar. Three corresponding angles that are congruent, meaning that the two triangles have the same shape. Corresponding sides are proportional. So that's going to tell us that they're not necessarily the same size. They're going to be proportional to one another. Okay, if the ratio equaled 1, then they would be the same size and they would also be congruent triangles. But if this ratio does not equal 1, they're going to be different sizes. Same shape, different sizes. So they're similar triangles. The ratios are all the same for all the sides. Then the sides are proportional. Okay, so let's find, in this triangle, let's find what these two pieces would be. Okay, so we know UV over XY. Okay, let's find what the ratio is going to be. Well, we know UV is 3 and XY is 12. So we're going to have 3 over 12. Well, 3 over 12 reduces to 1/4 if we divide the numerator and the denominator by 3. So the ratio is 1/4. Okay, so what do we know all the other ratios are going to equal? We all know they're going to equal 1/4. Okay, all the ratios are going to equal 1/4. So UW over XZ is going to equal 1/4. All the ratios are going to be equal to 1/4. Okay, we know UW is 5, and let's find XZ. So let's call it X. Let's call it A. Okay, the value of XZ is A. So we have UW, which is 5, over A is 1/4. Okay, how do we solve a proportion? Okay, we cross multiply. So we have 1 times A is A, and then we have 4 times 5. So A is going to be 20. We know VW over YZ is also going to be 1/4 because the ratios are all equal, and we know the ratio of UV over XY was 1/4. They gave us UV and XY, so we could find that the ratio is equal to 1/4, which means the other ratios are also equal to 1/4. Again, the ratios are comparing the sides, the corresponding sides of the triangle. Okay, so VW over YZ is going to equal 1/4. VW is 4. Let's call this B. ZY we're going to call B. So 4 over B equals 1/4. Cross multiply, we get B equals 4 times 4. B is going to equal 16, right? 1 times B is B. 4 times 4 is 16. B is going to be equal to 16. Okay, 16. Okay, and what do we notice here? Okay, 3 times 4 is 12. 5 times 4 is 20. 4 times 4 is 16. Okay, 20 times 1/4 is 5. 12 times 1/4 is 3. 16 times 1/4 is 4. So this triangle, the large triangle, is 4 times, right? Here's our ratio, okay, was 1/4. Okay, so this small triangle is 1/4 of the size of this triangle. This triangle is 4 times bigger than the small triangle, right? The big triangle is 4 times larger. The smaller one's 1/4 the size of the larger one. Okay, so all the ratios are the same. Congruent angles as depicted by the arcs. So since all these sides, all the ratios are the same, all the angles are congruent, we have similar triangles. Okay. In class, we practiced doing some proportions. We had this, so let me show you this real quick. So we kind of use this to try and demonstrate. So similar triangles, we can either scale up or scale down. Okay, so I just copy and pasted these triangles originally. So we had two triangles that were exactly the same, copy and pasted. They're congruent triangles. All the angles are the same, all the sides are the same length. Okay. When we have similar triangles, we're going to scale up or scale down. So it's going to maintain the same shape. Okay, we're either going to make it bigger or smaller. So this is basically what's happening. Okay, we're making it larger or smaller. So here we scaled it up. Let's assume we scaled it up by a factor of 2. If this was 3, 4, and 5, and we scaled up by a factor of 2, these sides would now be 6, 8, and 10. Okay, and if we found the proportion of those sides, 6 over 3 is 2. 8 over 4 is 2. 10 over 5 is 2. So all the ratios are equal. The sides are proportional. So if you have proportional sides and congruent angles, we have similar triangles. Okay. So now let's turn to the handout, the notes handout we got in class. There's a copy on the blog if you don't have them. Okay, what we're going to talk about are the three different ways we can prove that triangles are similar. So if we can show that all 3 angles are congruent and all 3 sides are proportional, we can show that the triangles are similar, but we don't need to show all that information. Okay, we have 3, what the textbook calls criterion. We can just call them postulates. I don't really see a big deal why we shouldn't be able to call them postulates. So let's just call them angle similarity postulates. And then we're going to have side similarity postulate and side similarity postulate. Okay, so the first one, okay, it says if 2 angles of one triangle are congruent to 2 angles of another triangle, then the 2 triangles are similar. Okay. So we had 5 of these for congruent triangles, right? We had side, angle, side, angle, side, angle, angle, side, and hypotenuse leg. For example, side said if we have 3 pairs of congruent sides, 3 corresponding sides, 3 pairs of corresponding sides that are congruent, then the triangles are congruent. Okay, here it's the same, similar to that, except we're going to say if we meet these criteria, then the triangles are similar. So the first one, if 2 angles of a triangle are congruent to 2 angles of another triangle, so if 2 pairs of corresponding angles are congruent, here AB is congruent to, or A is congruent to D, and angle B is congruent to angle E. So how many corresponding pairs of angles do we have? We have 2. So if we have 2 angles, we can say the triangles are similar. Okay. We can say the triangles are similar if we find 2 pairs of angles that are congruent. So example 1 and 2, can we use angle similarity to show that these 2 triangles are similar? Well, the first one, they're giving us angle A and angle D are both right angles. We know by the right angle theorem that all right angles are congruent. So we know angle A is congruent to angle D. It's given to us, or we could say right angle theorem, however we want. We also know by the vertical angle theorem that since angle ACB and angle DCE are vertical angles, that they're going to be congruent as well. So angle ACB is congruent to angle DCE, and that's because they are vertical angles. We now have two pairs of angles that are congruent. If the angle-angle similarity postulate tells us that if we have two pairs of angles, two pairs of corresponding angles that are congruent, the triangles are similar. So triangle, we can name this 6 different ways. Let's just call it ABC. Is going to be similar to triangle. Again, this is our similarity symbol. Just one squiggly line, one tilde. What corresponds with A? It's going to be D. They're the right angles. Okay, and then we go up to B, so we're going down to E, and then to the center at C. So triangle ABC is similar to triangle DEC by the angle-angle similarity postulate, which tells us if two pairs of angles are congruent, then the triangles are similar. Okay. So example 2, I redrew them. Okay, so let's redraw them over here. First, we have RSV. Okay, then we have a larger triangle, which is RTU. Okay, we know this is 12, this is 8, and this is 10. We know angle S and angle T are congruent, because those are given. Angle S is congruent to angle T, that is given to us. If we're going to use angle-angle, we need to find another pair of congruent angles. Well, we know angle R is going to be congruent to angle R by the reflexive property, right? All angles are equal to themselves. So angle R is congruent to angle R by the reflexive property of congruence. Reflexive property of congruence. Okay. Angle R is congruent to angle R. We now have two pairs of angles that are congruent, so we can say the triangles are similar by the angle-angle similarity postulate, or angle-angle similarity criterion, however you, let's just call it postulate. Triangle RSV. Again, there's 6 different ways we could have named the first triangle. Okay, what corresponds with R? R corresponds with R, so triangle RSV is similar to triangle R. S corresponds with T, and V corresponds with U. So that's going to be R, T, U. This question doesn't ask for RT, but if we added to it, find RT. Okay. We want to find the length of RT. Here's how we would do so. We know because two angles are congruent, two corresponding angles are congruent, two pairs of corresponding angles are congruent, that the triangles are similar. If we go back to the definition of similar triangles, we know all 3 pairs of angles are congruent and all 3 sides are proportional. So since we know they're similar, we know the sides are proportional. Proportional meaning the ratios are equal. So the ratios between the sides of the 2 triangles are equal. So let's set up a proportion to solve for RT. First, let's call RT X. The value of RT we're going to call X. What side corresponds with RS? That's going to be RT. So our first ratio is going to be RS over RT. Our second ratio is going to be SV. What corresponds with SV? It's TU. So SV corresponds with TU. Since the triangles are similar, the ratios, the sides are proportional, so our ratios are going to be equal. So we have an equal sign there. Okay, and then we can substitute in our value. So 10 over X is going to equal 8 over 12. Okay, to solve a proportion, we want to cross multiply. So we're going to get 8x is going to equal 10 times 12. Okay, 10 times 12 is 120. If you divide both sides by 8, we're going to get x equals 15. So RT is going to equal 15. If you can see it visually from these triangles, that's great. Awesome. Okay, but I would highly suggest redrawing the triangles lined up so that you can see which sides correspond to which sides, which angles correspond to which angles. It will help you out tremendously when the problems get more complicated. Okay, so that's angle. All right, the second one on your handout, right? So this is the handout. All right, it's got this. We took notes on this half. Here was the angle stuff we just did. The other side, we have side similarity and side angle side similarity. So let's do side similarity. And fit it all on the same page. Okay. So side congruence. Our side theorem for triangle congruence said that if you have three pairs of corresponding sides that are congruent, then the triangles are congruent. For this, we're saying if we have three pairs of corresponding sides that are proportional, okay, they worded it a little bit differently, but if we have three pairs of corresponding sides that are proportional, then the triangles are similar. Okay. So we don't need to find that we have three pairs of congruent angles and three corresponding sides that are proportional. We can just find three sides that are proportional. We know the whole thing is similar, meaning same shape, different sizes. Okay. And then here, bottom, it shows us what the ratios we can set up. So for these triangles, AB corresponds with DE. So our ratio is AB to DE equals BC to EF, which equals CA to FD. The ratios are equal. If these ratios are equal, then the triangles are similar. So if the three pairs of corresponding sides are proportional, then the triangles are similar. Okay. So here's our two examples. Example 3. Okay. We can flip the triangle over, or we can rotate it. There's two different ways we can do this. Let's flip it over. So I'm going to redraw it right here. Okay, so this would be P, this would be R, and this would be Q. This would be 2, 3, and 3. Okay. You could also rotate it, and then you would get R, P, and Q. Either way is fine. Since these two are the same length, we have isosceles triangles. So you're going to have actually two different sets of similar triangles. Okay. So let's set up our ratios. So what corresponds with PR is going to be SU. So PR corresponds with SU. Okay. PQ corresponds with ST. Okay. And then QR corresponds with TU. So here's our three ratios, right, that represent the comparison between the corresponding sides of the triangle. So here's one comparison, second comparison, third comparison. So three ratios. Okay, we know those ratios are equal if those ratios are equal. So if this ends up being true, then we know the triangles are similar. Okay, let's substitute in the numbers. So PR is 2, SU is 3. Here we get 3 over 4.5, and then we get 3 over 4.5 again. Okay. If you plug those all into your calculator, you're going to get 0.6667, etc., 0.6667, 0.6667. Okay, those are all going to be equal to 2/3. Doesn't matter if you have it as a decimal or a fraction, but this would reduce to 2 over 3, right? It's 1.5, or if we divide the top and the bottom by 1.5 each, we get 2 over 3. Okay, since all the ratios are equal, the ratios that compare the sides, the corresponding sides of the triangle, since all three of those pairs are equal, all three of the ratios are equal, the triangles are similar. So triangle, let's call it PRQ, is similar to triangle SUT. Right? The order matters in the second one. We can name the first one in 6 different ways. Whichever way you name it's fine, as long as your second one is the corresponding parts. So S corresponds with P, U corresponds with R, and T corresponds with Q. Example number 4. Okay, this one can be a little more difficult to visualize how you need to orient it. The way I do it is I simply look for the smallest numbers and the largest numbers. So if these two triangles are going to be similar, okay, meaning that they have the same shape, different sizes, then the two smallest sides will correspond with one another. So the side that has the two smallest lengths will be corresponding sides. So we could twist it, rotate it, and try to figure out which way, but it's hard to visualize. So let's look for the two smallest numbers, which is AC and FD. So we know AC and FD are corresponding sides. Okay. The middle numbers here are then 12 and 14.4. So we know BC and FE are corresponding sides. And we know that AB and DE are corresponding sides. Okay. We're going to use side similarity postulate. We need to show that these ratios are equal. Right? We need to show that the three sides are proportional. The way we do that is by showing that the ratios for each corresponding side, each pair of corresponding sides are equal. So if these three ratios are equal, then these sides are proportional. If the sides are proportional, all three sides are proportional, we know the triangles are similar. Okay, so AC, FD, that's going to be 10 over 12. Okay, BC over FE is going to be 12 over 14.4. And then we're going to have 15 over 18. If we reduce all these fractions, we're going to get 5 over 6. 5 6. 5 6. 5 6. So we know 5 6 equals 5 6 equals 5 6. Again, if you put them in the calculator and you come up with decimals, that's fine. You would get 0.833333 and so on. So you'd have 0.83333 for all of them. Either way, they're going to be all equal. All the ratios are equal, so we know the triangles are similar. So triangle ABC is similar to triangle, and we got to be careful here. What corresponds with A? So A is between the small and the large sides. So what corresponds with A has to be between the small and the large sides, which is going to be D. Then went to B, so B is between the large and the middle. Here's the large side, here's the middle. So it's going to be E. And then our last one is going to be F. So here we have similar triangles by the side similarity criterion, or side similarity postulate, if we want to call it that. Okay, so that's side. So far we have angle, which is if two pairs of angles are congruent, these triangles are similar, and we have side. Wait, side. I think I said one too many sides there. So if we have side. Okay, if we have angle, similarity criterion tells us if we have two pairs of congruent angles, then the triangles are similar. And side. Similarity criterion tells us if we have three pairs of corresponding sides that are proportional, right? Not congruent, but proportional, then the triangles are similar. Okay, the last one here is, what are we at? 30 minutes. Okay, last one is side angle side similarity. Okay. Which tells us that if we have, so side, angle, side, so we're going to have two sides and an angle. That's what's going to be relevant here. So if we have one pair of angle that's congruent, one pair of angles that are congruent, here we have angle A and angle A and angle D are congruent. And if two pairs of sides are proportional, then the triangles are similar by side, angle, side. All right, so if two sides of one triangle are proportional to two sides of another triangle and their included angles are congruent, then the triangles are similar. So we want the included angle, the angle that's between the two sides that are proportional. Okay. So example 5, determine if the triangles are similar by side angle side similarity. So we need an angle, and it needs to be the included angle. Okay, do we have one pair of angles that are congruent? Yes, we do. We know the measure of angle D and the measure of angle H are both 70 degrees. Since their angle measures are the same, the angles are congruent. So angle D and angle H are congruent. And then we look at our sides. So we know DE corresponds with HJ. And we know DF corresponds with HK. Okay, so we need to show, we already know that the angles are congruent. Okay, and that's the angle between these two sets of sides. So we need to show that those two pairs of corresponding sides are proportional, meaning we need to show that their ratios are equal. So 2/1 equals 5.8 over 2.9. That's 2. That's 2. 2 equals 2. We know the sides are proportional because their ratios are equal. They're both equal to 2. So we know the triangles are now going to be similar. Triangle DEF is similar to triangle HJK. How much? So again, they have similar meaning. They have 3 pairs of angles that are congruent and 3 pairs of sides that are proportional, right? The angles are congruent, the sides are proportional. The triangles are the same shape, different sizes. How much bigger is triangle DEF? Triangle DEF is 2 times bigger than the smaller triangle. And then the smaller triangle is half the size of the larger triangle. So if I asked you for a scaling factor, you would either say 2 or 1/2. Okay. Example 6, determine if the triangles are similar by side angle side similarity. So we need to find one pair of angles and show that they're congruent, and then we need to find the sides that go along with that angle, that make up that angle. We need to show that those sides are proportional, that the corresponding sides are, 2 pairs of corresponding sides are proportional. Okay, well, we have vertical angles, and we know vertical angles are always in all situations congruent. So angle TXU is congruent to angle VXW. Since those angles are congruent, okay, that satisfies our first condition, which is the angle part. Now we need to find the sides that are on each side of the angle, see if they are proportional. So XT corresponds with, or TX corresponds with VX, okay, and then UX corresponds with WX. Substitute the numbers in, 12 over 16 and 15 over 20. Okay, reduce the fractions. You can put them in the calculator if you want and get a decimal. It'll give you 0.75 for each one. Or we can just reduce the fractions. We should be able to reduce fractions. Divide the numerator and the denominator by 4. We get 3/4. Divide the numerator and the denominator by 5, and we get 3/4. 3/4 equals 3/4. So the ratios, right, comparing the sides, the corresponding sides, right, the two ratios that compare the corresponding sides, those are equal. So that means the sides are proportional. Since we have two pairs of proportional, since two pairs of corresponding sides are proportional and the occluded angles are congruent, that means the triangles are similar. So triangle TXU is similar to triangle VXW. Again, there's a bunch of different ways we can name the first one. Then the second one has to be in the correct order where you match the corresponding vertices of the triangle. Okay. So those were the basic, that was most of the notes we took on Thursday and Friday if you're in 4th and 5th hour, and Tuesday and Thursday if you're in 1st, 2nd, or 3rd hour.